with planes of symmetry. Okay, so I'm going to go quickly through this problem where two planes of symmetry are used in one situation. For example, when the two ends are welded against the two ends. Obviously, everything's symmetric along the perpendicular direction. But if I do only welding of one edge of the cylinder or shaft with one edge of the left bearing, this side is completely free, then this vertical plane towards you is not a plane of symmetry anymore. There's only one, which is along the length of the shaft. Okay, and that's how I did the problem last time, except that I didn't use symmetry. So I'm going to quickly go through that, the creation of the model from the beginning, without any dimensions. Okay, any specific dimension. I just make one dimension visible to myself so that I know what the sizes are. All right, so let's go ahead here, and this is the agenda. First, we're going to do this problem, wrap it up, and then we move on to chapter 15, which is a shrink fit problem, and your homework tomorrow is related to this item. Okay, so let's go ahead here. Automatically, a product file is, of course, activated, so I'm going to insert my first part in it. So insert, new part, in this. I'm going to double click on it. This is going to be the shaft. So let me actually call this thing a shaft. Properties, shaft. And shaft. Okay. One of them is a part name. The other one is the instance name. All right. Notice that that's because I gave them the same name, it became shaft, parentheses, shaft. Okay. So it's instance shaft. So let's make this thing. We are already in part design. So on that vertical plane, I will sketch. Let me do the shaft, which was roughly one inch diameter. Dimensions are not important right now. So yeah, so let me actually make this half an inch. Yeah, half an inch radius or 1 inch diameter. 0.5. Exit. Padded by say 10 inches each way. Let me see how it looks like. If I do 5 inches each way, mirror extend, it's going to look like that. Yeah, why not? We make it like this. Now I did create a stand on top of this because I want to apply the load on that stand. Okay. In the book, the load, downward load, is applied to the entire shaft, which is physically impossible to do. Okay. So on the way I did it on that horizontal plane, I sketched. Okay, so you know what? This time I'm going to make a rectangle. How about that? Instead of making a circular thingy, I'm going to make it like that. Why not? Exit and then pad it. Let's bring it down, 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 down. Okay, that's too much down. So maybe 0.7 maybe. Okay, good. I'm going to put the load on this. Now, somebody asked me the other day, I made it a bit taller, said that, well, shouldn't it be, shorter? Well, I mean, this is just something that I make to put the load on it instead of putting on the whole shaft. The real life is a different story. If you are sitting on that shaft, okay, there's not even a stand there. Okay, so what you need to do, put your load on a particular area, patch, and that you have to create. You need a feature to put your load on it. Okay, you need a feature. This feature can be something like that, or it can be a surface on that shaft that I have created, and you proceed along that line. Okay, so I'll just leave it like this. The emphasis in these things is doing assemblies. It's not how the load is applied. Okay, so that's good. Let's go ahead and create one of the bearings. So insert a new part. Always say no. I always say no. You can read it and see what it actually says. So on that vertical plane, I will sketch. Why don't I project, because I'm lazy, I'm going to project this circle. Automatically, the circle is over here instead of me drawing it and dimensioning it. And now we're going to do the rest of the problem. It's yellow because it's a projection. Good question for the test. It's yellow because you circle the right one. Okay. Something like this, and like that, and this, and that. I want to make sure the symmetric, concentric here. So this circle control that circle because I know that the centers are probably not the same place. You can see that it's a little bit shifted. I want to make it concentric. Yeah, now it's okay. And knowing the diameter of a shaft is 1 inch, you have a fairly good idea what these things are. Exit, padded. Yeah, that's good. I'll make it the same. Okay. So this is going to be my bearing. So let me right-click Properties Bearing. And bearing. Okay. And save everything. So in File, Save Management, Save As, Desktop, New Folder. Okay, Problem 1. We're going to go there. Propagate Directory. So Propagate Directory basically put everything associated with that problem in that folder. Everything. Okay. Good. Now let's make everything out of steel first of all. So apply material. Everything made out of steel. Say OK. Now, when it comes to the other bearing, I mentioned that you can actually go ahead and do another one of these, just like you did here, under a different part. Or you can copy and paste it. Okay. Or after you save, you can insert an existing component. Let me do that this way today, okay, instead of copying and pasting. So I say insert, not a new part, existing component, you click on it, and it says, where do you want to insert this in this product? And it says, where is it? So I go to the folder that I created, and I saved it immediately before I did this, grab the bearing, and bring it in. So I go, it's problem 1, that's this one. Notice the product is there. The shaft is there. The bearing that I made and saved is there. So I'm going to select the bearing and I'm going to bring an instance of it into the structure. And you'll notice that there is a bearing here, another bearing. Now, the reason you may want to do that is that if you copy paste or if you literally make the parts, these will take there's overhead associated with it. It takes disk space and all these things. This is not creating another part. It says, hey, I have a part that I have saved and I want to use it for some other purpose. In this case, the problem that you see here. Now they're sitting on top of each other. So if you move these things, for example, if I translate in the X direction, you see that there are actually multiple copies, 2 copies, because I created one and inserted a copy of that, and a component, an instance of that, basically. Okay, rest of the problem. First of all, I suggested that you anchor something. Okay, anchor. This is the correct constraints toolbar. There is something that looks like an anchor, and I'm going to anchor the shaft so that when you move things around, this guy stays put. Okay, so for example, this is very easy. I say coincidence between this face and okay, that face. Now, when I do this, if I don't pay attention here to these arrows, what happens is you update, you see that it's going to look like this. In other words, I want this thing to be flipped around. Without actually rotating these things and do this kind of a thing, I can actually go to that constraint that I created, flip the arrows, and hopefully they'll take care of it. this arrow, one of them you flip, and you update. It did the right thing, except that just like last time it did rotate there. Yeah, so let me, and the different ways we can fix this. For example, you can say, okay, let me maybe literally rotate this manually about the x-axis so that it's closer to where it was before, what I want. Okay, let's do this one. Coincidence between this, and I'm doing the same thing. Coincidence between the other side and this side, okay, and update. Okay, good. And if you want me these things to line up, coincidence between this plane and that plane, and update. Okay. Whoops. See, it's tilted. But that's easy. That's easy because what we can do is say angle constraint between this plane and, for example, the bottom plane. And I want this thing to be parallel, right? Parallel. There we are. Look, you've got to make this thing somehow. I don't care how you do it. That's your part. Now, on the test, if there is an assembly problem like this, obviously you have to solve it as an assembly. Second thing is that making a geometry has a few points. Just the homework tomorrow in the lab is actually from last year. It'll give you the breakdown of the marks, how we marked it. First of all, if you did something that didn't run for whatever reason, automatically, whatever number of points that problem has is going to be discounted by 35%. Because at the end of 6 weeks, not 6 years, 6 weeks, you should be able to run it at least. If it's not running, something you're not doing right. Fundamentally, after 6 weeks, you're doing something fundamentally wrong, and you're going to lose 35% automatically on it. The rest of it, even though it didn't run, we look at the rest of the stuff. Did you correctly take symmetry consideration? Did you put the correct restraint? Did you put the okay? Depending on that, we discounted by 35%. You get your marks. Okay, so if you have any question about this marking scheme, talk to me tomorrow. It's on your homework. Now, okay, very good, and we have to cut it now. You can go to individual parts and cut them, but you can also do it in the assembly. For example, there is a saw in the assembly right here. Look, notice that I am in the assembly zone right there. There is a saw there. This saw will, what is it? If sometimes you don't get any feedback, just read this. Select FA, a plane or a face, surface, or an existing split. So I want to cut it with, for example, this plane. It says, okay, if you're going to cut it with this plane, then three things are affected. You can see that shaft, bearing, bearing. Do you want all of them to be cut? If the answer is yes, just say yes, all of them. Which side do you want to pick? Doesn't matter. Oh, undo. Let's try to do it differently. So again, I select my plane. Which plane? This plane. Read this thing carefully. What does it say? It says affected parts. Let's take the shaft. Let's take this and take that. Ooh. Undo. Okay. When it comes to this and you don't have the time, and you don't have the time right now, split them one by one. And I wonder why it's happening like this. I'm not sure. Why they're not cut at the same time? They should be, unless I'm overlooking something. Let me try one more time. Parts possibly affected. Okay. All right. You know what I'm gonna do? I'm gonna try to do. How many things do I have here? Let me see for a second. this and that and that. Who knows? I'm not sure why it's not working. So let's do it one at a time. Something is not working, and I can't even close. Oh, okay. Listen, I don't know why it's not cutting it at the same time. So let's go ahead and do it again. Do it again. Question? Comment? Okay, so let's do another one. Do another one mean another part. What can I do? So bearing. Oh no. Where is that assembly? Okay. Let me delete these. Man, I didn't expect to get bogged down here. Okay. Since I have miserably failed in doing what I wanted to show you, what I'm going to do is I'm going to go to parts individually, cut them. I went to the shaft, get the split out. I don't know why it's not working. I don't know. So you want me to go back here? So let's see. So it says select the plane. Okay, so that's this plane. And then it cuts the shaft. You want me to try this bearing? I'm wasting too much time on the test. Okay, you can get to the bottom of this yourself because I failed to do that. Okay, so because these things happen, you either have to bite the bullet and do it a different way, or spend time, hours, or not hours, minutes on it trying to get something done. It's entirely up to you. Okay, so let's try this. This is going to be the shaft. You keep that side, no problem. Go to the other part. Go to the other part. Now here, if I split one, the other one might get split too, which is fine. I don't mind. So split that plane. Yeah, it did it. But look what happened. Okay, then look what happened. Because of the way, remember, probably I rotated these things. Now here you have to decide what you're going to do. You can take this thing and remove the constraint, put it on the other side. Okay, and there's or yeah. So let me do the following. This constraint was for these ends. Okay, let me delete this. I have to go to the assembly to do that. Okay. That is the one disadvantage of doing instances. Okay. Uh, but if you had copied it and you cut the other bearing, it'll ask you which side you want to keep. Happens. Okay, so let me delete this. Let me delete that. Let me delete this. And now we're going to move this. We're going to go to the assembly and move this thing to the right place. So let me see. Rotate about the z-axis like that. Okay. Translate it in the x direction. Ooh, translate in the x direction like this. Let's try to put constraint between this face and that face and pray. That's good. That's good, except that we're not done yet. So coincidence between this axis and that axis, update. There. Okay? I'm not going to waste any more time on this thing. So, and in fact, I'm not going to do two planes of symmetry. Okay? So, but it is on the video. You can watch it. Okay, so video from last year. Or I may have a better luck and be the second group. I'll try to record this thing. Yeah. This one, I'm intending to weld only one side. Yes, I'm intending to do only one side. Therefore, it does have one plane. But if I had done welded on both sides, then this vertical, yeah, that's also there. Let's move on. So we go to human builder. We don't want to go there. Catia immediately sees three parts. It's going to mesh it. It's going to mesh it. So, but you know what we did last time? We made the local mesh refinement around the hole. I think with this group I made everything small, but with the second group that I posted the video, I actually around the edge of that stand I made it smaller. You may want to look at that if you want. With you guys, when we did this problem, I made everything smaller for the shaft. Okay. Okay, good. So let's do the rest of the problem. All right, the bottoms are clamped, and somebody asked me, I think it was in this section, somebody asked about that anchor. Wouldn't that, kind of clamp something? No, that stuff that we did with assembly constraints will not transfer into generative structure analysis. Okay, so you have to do, all these things have to be done. Okay, so let's put a load here. And remember, if you are dealing with a force, then you divide whatever the force is by 2. Okay, so let's pretend that there was 2,000 pounds here. I think last on Tuesday it was 2,000 pounds of the whole thing, or 1,000. Anyway, divided by 2. If it's pressure, leave it the way it is. Okay, so good. Now we need to do connections. Surface sliders. Not here. Under restraint. Surface slider. This is a plane of symmetry. That's a plane of symmetry. This is a plane of symmetry. This is a plane of symmetry. And this is a plane of symmetry. Any one of these missing on the test, that particular component, maybe 3.4 point out of 26, is going to be deducted. No part marks. Okay? So pay attention to what you're doing, please. I know it may not be, you might not consider it to be fair, but there must be a distinction between somebody who doesn't make a mistake and somebody who does, inadvertently or on purpose. All right, so now we create a connection, one on this side, on this face, and then hide this, the inside of the hole as the second component. Good. And do another one between inside of the hole, because it just happens to be available to me on the screen. And the second component is the face of that thing, the face of that shaft. So let's bring this thing in the front. Okay, good. So 2 connections have been created, and that's signified by either looking at the tree, 2 of them, or these red lines will tell you that it was okay. What kind of a connection is this? If you bought this shaft and brought it home and stuck it into there, what would the nature of the connection be? This is saying they're friends and enemies and relatives and things like that. It doesn't say how. Connection simply means there is a relationship between this guy and that guy, this surface and that surface. It doesn't say how. If the problem statement says these are fully bonded, that end that I put in there is fully bonded, fully glued, whatever, then it's going to be faster. Otherwise, it's a contact. It's a contact connection. So you go to contact. I think this is contact. What is it? Second one. So this is a contact. You just cannot penetrate that. And this is a contact. And that's signified by those, see this? You see these 2 things on top of each other, next to each other, it looks like contact. And don't fool around with these. Just to make sure, if you're that confident that you know that what you're doing, then fine. But I didn't say anything about friction coefficient, therefore you should not use it. Okay. for example. That's an example. Now, if we run this thing, it's not going to work because this whole thing slides out. So the problem clearly says, take the edge of the shaft and weld it to the edge of the hole. The problem will say that. So what you do is do a third connection. Okay, it's easier if I hit this thing. So the first component is the edge of this shaft, and the second component is the edge of that hole. You got to be very careful here because edge of that hole is that sketch. So you have to hide this and then select that edge. Because if you try to pick it with that sketch there, you won't take it. Simple as that. So bring it there, and this is the third connection. Because they're fully bonded or glued or fully perfectly glued, bonded, welded, you make it fasten. Third one on here, you say okay. Hopefully we didn't do anything, we didn't forget anything, so we're going to run it. Now, notice that when I opened that window, it didn't give me anything. Usually it says all. So what I did, I used the pull-down menu and selected all. For some reason, it didn't give me that. I don't know. So that's what I'm saying. If you cannot run, possibly because you can't find that thing. You see a blank box there. So I used the pull-down menu, selected all, and then I could pick it. But if you didn't know what to do with that, it won't run. So unfortunately, 35% is down to 2. Now, it doesn't have to be like that, because if you have done your work and you saved it, then you exit Catia back into it. This time, do the analysis, just everything, put it into place, and run it. Okay, so sometimes, not a big deal. There we are. I'm not going to do any more of this. Okay. Notice that because this side is not welded, as this thing bends, it just slides out. Okay, if both sides are welded, then you need 2 planes of symmetry. Okay, and then of course half of it you don't even do. All right, any questions? All right, so good.